Okay, example 17. In any assessment, I will not have you graph this. Instead, this is the way I will present information so that you understand the graphing piece without needing to graph. I've already expected that you've graphed those examples for the previous part of the homework. If you have not done that, please go back and do so. But for any assessment standpoint, any assessment standpoint, I will be giving you the question in this way. So what I'm doing here is I'm telling you that there is a straight line when I plot concentration versus time. And then the slope of that straight line is this. So this information is given from if you had graphed it. Okay, so what you're imagining for a moment is that this was graphed from data and you got a straight line. The straightest line, the most linear plot of the three plots was when you plotted concentration versus time, and then you took the slope of that line and you were able to get this value. So from that, we're going to determine the order of the reaction, and we're going to justify our answer. So the important part here is plot of concentration versus time is straight line, and we know that when we plot concentration versus time here, it gives us a zero order plot. So it's zero order, zero order reactant. So here's how you would answer that to justify it. Zero order as a linear plot or straight line for concentration versus time. I don't care if you use the phrase linear plot or straight line, but I expect that you can tell me that it's zero order or first order or second order based on the type of plot we have that is a straight line. We're going to calculate K. We can do that from the slope, right? We know slope is equal and opposite in sign to K. So if we know the slope, we take the opposite sign of that and we have K. That's what I did here to get K. I knew the slope was this. I took the opposite sign and I got K. 17C says if the initial concentration of the reactant was 2.153 times 10 to the negative third molar, calculate the half-life for this reaction. And then we're expecting to get this answer on our calculator. So we need to think about going back. Sorry, I went the wrong way. We're going to go back to here. We know half-life for zero order. T to the half is A naught over twice K. So we have T to the half order is A naught over twice K. Remember, requirement is to have that generic formula. I'm plugging in my initial concentration. I'm plugging in 2 times my K. This is the K because we know it's the opposite of slope. We figured this out on part B. And when I get that, I get 1.25 seconds. For part D, how much time is required for 85.59% of a 0.366 molar solution of the reactant to decompose? We have a percent. We must decide if that percent represents percent remains or percent used. If it decomposes, it means it used up, right? Decomposes mean it's used. So we're going to have to subtract from 100. We're going to subtract from 100. 100 minus 85.59 is 1441. And now we can put A over A naught equals percent remains. Remember, you have to write that percent as a decimal. We're going to put in our initial concentration, our A naught, underneath where it belongs, as you can follow through. We're going to cross multiply and we're going to get our A to be 0.05280 molar. I expect this part to be shown on any calculation you do. So now we can solve for time. This is the formula, the generic formula that you must show from the zero order. So we're going to put A naught minus A equals K times T. When I subtract these two, I get this. This is my K. I divide both sides by my K to solve for T, to get T by itself, and I get this. Again, please check using your calculator to make sure you can obtain my answer. 17E, how much time is required for 48.23% of a 0.4006 molar solution of a reactant to remain? So we got to decide, what is this always, when we given a percent, is it describing or representing a percent remains or a percent used? It actually says the word remains, so it's easy to know it's remains. Therefore, we do not need to subtract from 100. We're already at percent remains. We know percent remains equals A over A naught. A over A naught equals 0.423 as a percent. Cross multiply. Again, put this over 1, cross multiply. We get A to be 0.1932. Generic formula is given as we have been expected to show. 0.4006 is my A naught minus 0.1932 molar. When I subtract those two, I get this. And then, of course, my K times my T. I'm going to divide both sides by K, and I get 241.7 seconds.